Hi, this is Alex from devstories.eu. Docker Masterclass, Episode 5 of 18. If your Docker build takes 10 minutes every time you change one single line of source code, you are doing it wrong. The fix is entirely in how you structure your file, and that means mastering the build cache. When you trigger a Docker build, the builder processes your Docker file sequentially from top to bottom. Every single instruction, whether it is copying a directory or running a script, generates a separate layer in the resulting image. Because executing these steps requires compute time and network bandwidth, Docker automatically saves the output of each step into a local build cache. On subsequent builds, the engine attempts to reuse these saved layers to skip redundant work. To determine if a cache hit is possible, Docker evaluates each instruction against the existing cache history. For instructions that run commands, it checks if the command string itself is identical to the one used in the previous build. For instructions that copy files from your host machine into the image, Docker goes a step further. It calculates a checksum for the contents and metadata of every file being copied. It then compares this new checksum to the checksum of files in the previously cached layer. If the checksums match perfectly, Docker reuses the cached layer and proceeds to the next line. If even a single byte differs, the cache is invalidated. Pay attention to this bit. Cache invalidation is a strict chain reaction. The instant Docker detects a change and invalidates a layer, it stops looking at the cache for the rest of the build. Every single instruction that comes after the invalidated layer is forced to execute from scratch. This happens because each layer relies on the exact state of the layer before it. This chain reaction dictates how you must organize your Docker file. Consider a node application where you manage external dependencies. A frequent mistake is using a single instruction to copy your entire project folder into the image, followed by an instruction to run your package installation command. If you modify a single line in a text file somewhere in your source code, the checksum for the copy instruction changes. The cache breaks at that step. Consequently, the next instruction is forced to run. You wait for hundreds of megabytes of dependencies to download again, even though your actual list of dependencies remained entirely untouched. The optimal approach isolates the dependencies from the application code. First, you add an instruction to copy only your dependency configuration file, specifically your package manifest, into the image. Second, you run the command to download the dependencies. Third, you add a separate instruction to copy the rest of your general source code. Now, when you modify that same text file and rebuild, Docker evaluates the first instruction. The dependency manifest has not changed, so the cache is used. It moves to the installation step. Since the preceding layer was a cache hit and the command string is identical, the cache is used here again, skipping the massive download. The cache only breaks at the final instruction where the builder copies your updated source files. A 10-minute wait becomes a 2-second update. The most effective way to speed up your pipeline is to order your instructions strictly from the least likely to change to the most likely to change. That is all for this one. Thanks for listening and keep building.